I think I saw a cat.
I know, I'm sorry.
Oh, that's perfect.
Me shadow.
What's your minimum specification? So hi everyone, and welcome to another of Ian's interviews. Today we have a really special guest from Intel. She is the EVP and GM of Intel's Technology Development Group. Joining me today is Dr. Anne Kelleher. You lot have requested this interview for so long, and I'm so glad to be able to spend some time with her. Anne, thank you for putting time in your schedule for me to ask you some really serious questions. I hope you're ready.
Well, thank you, Ian, and it's my pleasure to be here with you.
So going through your history, which I mean by I checked your LinkedIn, you joined Intel early 96, which makes you a 26-year veteran of the company, what I like to call an Intel lifer, working up from process engineer to now being GM of technology development, or TD. So what exactly has been your journey through Intel?
Well, I'll start back in 1996, and maybe I even start a little bit before 1996. When I was in college, I did a master's and a PhD. And when I finished up my PhD, and I did it in a research centre in Ireland, which was called National Microelectronics Research Centre, which was in Cork. And then when I finished there, I went to IMEC in Belgium and I did a postdoc. And then I returned to Ireland after that. And was leading a small research group, again in the same research institute. And Intel Ireland was starting up a factory at the time, a new factory, Fab 14, and they were hiring for Fab 14. And at the time, they basically asked me to come talk to them, asked me to come interview, and I did. And I got the job. And at the time, I thought I would come for a lot of my job pre joining Intel was basically writing project proposals, so I would have enough money in research to fund the group that I was leading. And one of the challenges in that was I always had to write down what my industrial experience was. And I hadn't worked in industry at that point, so I would always try and explain all the projects I'd done with industry. So when Intel Ireland offered me the job, I thought I'll go work in Intel Ireland in industry for a year or two, and I'll tick that box, and then I'll go back to research. But I found when I joined Intel Ireland and when I joined Intel overall, the pace of Intel was much faster than the pace that in research. And it allowed me so much opportunity within from a career perspective, from a growth perspective, from a learning perspective, from a job change perspective, that it basically really suited me. And I would say over the last 26 years, Intel's been really good to me. Now, I've done very well. I've worked very hard. I've delivered a lot, but I think we were a match. So instead of staying 2 years, I've been with Intel 26.
So starting as that sort of process engineer, going through your history, you've gone from process to fab management to now being general manager of TD. What experiences from managing the fab side of things translate to your current role? It going from managing a fab to managing how new process nodes are developed. There's some synergies there, but it's not quite, a direct circle overlap from my perspective at least.
Well, maybe I'll walk a little bit in my career in manufacturing, then I'll talk about how it applies over into technology development. So, as I just said, I came into the manufacturing world from a research development background. And then when I came I worked as a process engineer first, then I became a group leader, then I became a department manager, and then I became a factory manager. But one of the things that I had always been doing within, and then I moved from Ireland to the United States, and I was a plant manager in Arizona, and then I became a site manager in New Mexico, and then I became head of the fab, basically a co-head of the fabs, and then I became co-head of TMG, and then I was manufacturing again, and then now to TD. But my journey within, a lot of my time and my journey within Intel, within the manufacturing organization was, I did a lot of technology transfers from TD into the factories. So I would have spent my life with Intel over the 26 years was Ireland, California for seed assignment for technology transfer, Phoenix for technology transfer, Ireland, California for tech transfer, Ireland, Oregon for tech transfer, Ireland, and then I went to Arizona, and then I was in New Mexico for tech transfer. So a lot of my time over the years was spent in close working while I wasn't working directly on development, was closely working with the technology development organization, bringing the technologies into manufacturing. Now, when you're bringing in and starting up the technology, in manufacturing, you have to learn a lot about the technology itself. You have to learn a lot about how it was made and how you can set it up so you can ensure that it runs with success. So within that journey, I became very appreciative of the work that the technology development organization needed to do. But I also became very appreciative of the work that the manufacturing organization needed to do so that you could get the best of both worlds. So then when I came over to TD, I brought my skills and my learning, I would say, from the customer side within the manufacturing side into TD. I brought my past learning in terms of all those technology transfers and the time that I spent as what we call seed within the technology development organization. And I also brought, I will say, my life pre-Intel. So I brought a mixture, and I brought a deep appreciation for the technical skills that my organization has. I would say my organization has some of the, I would say, I have many of the leading engineers and scientists within the world. So it gave me a chance to bring my experience to marry with their experience so that together we get the best of both worlds.
So for those people who are reading, watching this interview, who haven't heard of Intel's technology development team before, how would you characterize it compared to what Intel traditionally promotes as its R&D?
So within the technology R&D, we focus on process development and we focus on packaging development. So the overall R&D umbrella at Intel captures many aspects of R&D. There is circuit design, there is our labs, and I know you've done a past interview with our labs. There's all of that aspect, but the aspect within that we cover in R&D is process development, and basically where the silicon wafers are basically we process on the silicon wafers and we develop the next generation technology that gets used in our next generation products. Equally well, we do packaging development, and that is again development of the next generation type of packages that can basically package in our products. So between the combination of our next generation technology and packaging, we're able to deliver our future products. I view the process and technology, I would say, as some of the heart of Intel in terms of, because if we do our job really well, we deliver not just the present, but we're making the future. And I tell my team that we need to deliver really well the present, but we're also making the future.
So when we traditionally speak to Intel about future development, they talk about stuff that's coming up in 1 to 3 years as being very immediate. Then we have research to 5 years out, and then what I believe is called pathfinding, sort of 7 years plus. Can you kind of talk about how much mental space each of those take up?
Well, I think it varies in any given week and it varies in any given 6 months, right? And let's be honest, when I came over to TD first, my entire first 6 months was on process. I gave a little bit of time to the rest, but I was really focused on process. Within the last 6 months, and actually now going into 2022, I'm spending a lot more time focusing on what we call components research and the future. My team had a very extensive set of publications at IEDM in December timeframe. But one of the things is what we do in components research is all about, I call them the innovations that is enabling moving the frontier of Moore's Law. That is absolutely critical. It is absolutely valued by me. And in 2022, a lot of my attention units will be in that space.
So going to what's kind of in the news today, because semiconductor development has often been quoted as the industry where you bet the company every generation, especially for companies like Intel when you're on the leading edge. And it's no secret that new CEO Pat Gelsinger is publicly stating that Intel is going to accelerate its process node rollout. I think he's talking about 5 nodes within the next 4 years, or 4 nodes within 5. This would arguably be the fastest development in semiconductor history. But Intel has gone through some of its slowest nodes development, taking a while to get to 10 nanometer and higher yielding, profitable situation with acceptable margins. It seems a large task to pivot from what has been a slow period from Intel to the industry's fastest ever ramp up of new technologies. You've been in this position for 18 months. Can you speak to what strategic changes you've put in place that compared to what was done previously to execute on Pat's vision? I know when we spoke last, you mentioned backup strategies, and I really liked that. But what else is going on to execute on that strategy?
And absolutely, Ian, and I'll talk a lot. I'll expand a lot more than when we spoke last. I think some of what I'll talk about had started already when I joined, and a lot more I have been working with the team since I joined. I break it down into a number of portions. First of all, I'm very focused on predictable execution. I bring that from my background in manufacturing, and I bring that from my own core. I like getting stuff done, and I like getting stuff done on time, right? And I've been that pre-Intel, and I'm that way within Intel. So a lot of focus. So then to get within predictable execution, we have broken down into many portions, right? I spoke to you before about our risk assessment methodology, and we're looking at where we need to do contingency plans. And then within those contingency plans, at what time does it make sense, how long to continue them, and what is the right time to cut across and move from the primary plan to the contingency plan. We have that in place since August of 2020, and that was one of the actions we did on our 1276. Our Intel 4, and that has been working very successfully for us. We also have started a lot. Over the years, we've done a lot of work with the ecosystem, but we've also we've enhanced that work. We've taken it to the next level, and I'll break it down into our equipment and materials vendors or suppliers, and our EDA tool suppliers. We have spent a lot of extra focus in terms of how do we make sure we're learning from the ecosystem? We don't need to learn everything ourselves. What's key is we keep the innovation in the key places to get to be parity and get ahead, and then take what is within the ecosystem and learn from that. So we have a very active focus on that, and that has been working well for us. We've also been very focused on adopting industry standards. Industry standards, particularly as we talk around process design kits or PDKs and all the working with the EDA vendors. There's a lot of industry standards out there that we have picked and placed and brought in. Now, one of the things is that we're doing is bringing those industry standards, and at the same time, looking where we have, I would say, best from IDM, and how do we marry both of those together. The other thing is, and I say this many, many times, I work with some of the best engineers in the world within this organization. And I also did some organizational, structural, and management changes over the last 18 months so that we are very, I would say, more streamlined, very clear on where we're going, very clear on the mission, very clear on the deliverables, very clear, are we on schedule, very clear on have we opportunities to do stuff earlier. So there's a lot of focus, I would say. So it's, as well as that, we have that focus on innovation. So not going away from that, we continue that. So I would name it as focused on innovation, discipline, and around our execution. Basically, all our risk assessments and contingency planning, getting the best from our equipment vendors and equipment and material suppliers are basically our EDA suppliers. So it's across many fronts, but all of those we're actively working and actively monitoring that we've said, here's what we're going to do, and we're doing what we're saying.
So is this the Gelsinger era of Intel or the Kelleher era of Intel? You don't have to answer that.
Pat is our CEO, and Pat has done a wonderful job since he's joined us. And he's been really, really supportive. I know I said some of this work has started before Pat joined, but one of the key things is that he has been really supportive. part of the focus we also did was built a very detailed roadmap on how we get back to parity and get back to leadership, which we would have shared last July. But that needed money and funding, right? So Pat was very happy to sign the check.
So Pat's vision of foundry services combined with current semiconductor demand seems to require a diverse portfolio of nodes, not only those on the leading edge, but also more commodity. With Intel's got 22 FFL, and we're hearing about a new 17, 16 nanometer node. But we see other foundries offering analog, RF, high voltage, also packaging. How diverse does Intel need its offering to be, especially across its global infrastructure?
I'll start with saying what I'm very focused on, and then and I think and what I view as my key first steps in enabling IFS to be exquisitely successful. I'm very focused on getting from our leading nodes, getting back to ensuring we're at parity and at leadership on our Intel 20A and our Intel 18A. I'm also very focused on, yes, we run 22 FFL and our Intel 16. We're very focused on making sure that that's ready for our foundry customers. Beyond that, there's a lot of other items that could be on our docket, could be on our table. But for me, my first protocol, my first deliverable is deliver those exquisite and successful. And then when we get beyond that, we can talk about adding more.
Awesome. You mentioned earlier about the standardization, using industry standards, and then combining that with your PDKs to offer something to future IFS customers, but also for use internally. I guess part of my question is, why was Intel using so many custom tools in advance? But also, how has that pivot been to moving from these completely custom tools to something more industry standard that you can promote as an IFS offering?
Well, if I go back over the years, and I think this is more a historical answer in terms of why were we doing custom tools. We were in IDM. We were in IDM that was servicing our own internal customer products, our own design teams. And thereby, over the time, we had built a suite of tools that had worked for that, right? And they worked for that, but and we have progressed down one path. The rest of the world, as particularly those with the foundries, basically needed to establish that standardized set of tools and needed to put those standards in place so that they could go from basically, I would say, tech node to tech node and actually maintain that standard for their customers. Right. So I think historically it was we were in different places. We were servicing internal versus external. As we pivot over to support our external customers, we had started this pivot even before Pat had announced the IFS. We had started that pivot because there was a very large external ecosystem which had developed a very robust set of software, right? It did not make a lot of sense to continue to try and do that and hit the same point for our own internal suite of tools. So it made a lot of sense to start pivoting over to that internal and external standards. Now, there are cases where we have some unique tools from our past and our history, which are a definite benefit, which we have held on to, but they're in addition to. So the pivot started probably in late 19, early 2020 timeframe. The teams, it's been very well received internally by our internal design teams because, again, it has set the standard for them in terms of things are not changing at the rate that they had before. And it means there's a very clear standard for which they can work for. Ease of use of design is one of the metrics we look at. And based on all the work that's been done, our ease of use, we benchmark with external across the external foundry world, and our ease of use has significantly improved, and we believe we're heading towards the best in class based on the work that's been done.
So when it comes to new leading edge process nodes, we're hearing of stories of kind of internal battles inside Intel when it comes to installing and ramping new process nodes between the different fabs. It sounds like Lehman Burdoin will be the first for Intel 4 production. the fab in Ireland, but how much does TD itself get involved with the rollout of new nodes beyond the development stage? And how cognizant does it have to be of, say, the abilities, resources, local infrastructure of the fabs that will eventually be manufacturing that node?
Well, Intel Ireland, which is, first of all, we have an entire, maybe I'll back up and answer the question. First of all, there's an entire process by which goes through as part of our long range planning into the decision on which factory gets the next node. I used to run that when I ran manufacturing. Kevon runs that now because he runs manufacturing. Technology development owns the technology transfer to our first HVM. So I need to be, and my team need to be very cognizant, and we work, I will say, hand in hand in terms of working teams together to ensure the success of the transfer into the first fab. We've always done that. We've already very active teams ongoing with for Intel 4. That work is well under progress. So it's not a case of there you go, good luck and it's yours. I feel ownership, TD feels ownership until all the factories are completely matched and are at the levels and health that we would expect them to be at.
So for part of this interview, I kind of want to look back on some of the learnings Intel has done, given recent struggles with Intel 10 nanometer. It's been noted both product and financial, and I know this is kind of before your current role, but would you be able to go into how the development process of 10 nanometer and its challenges have provided experience into how Intel might approach similar in the future?
I think if I go to the highest level, one of 10 nanometer was basically was attempting and aiming at getting very, very aggressive scaling. And I think in the desire to achieve that very aggressive scaling, um, and EUV wasn't ready at the time when 10 nanometer node was being defined. Had EUV been ready at that particular point in time, I think 10 nanometer would basically not have had the challenges that it had. Out of that, we took significant learnings. Our risk assessment process is one, right? Our also in terms of when EUV became ready, it was too late to go back and insert it into 10 nanometer based on the way the architecture had been designed. Another key thing we're building a lot more flexibility in to as we're going forward for our future process nodes, because we've overtly said we will always be on the leading edge of litho going forward. So we're designing our process nodes so that if a new piece of leading litho becomes available and ready, that we can cut it in as soon as possible without being in the space of where it's too late to cut it in. So I think there is that aggressive scaling that is there. EUV wasn't ready, and by the time it was ready, we couldn't cut it in. So it is basically we have taken learnings around building in a lot more flexibility in terms of how we set ourselves up for future nodes, and as well as that, the key risk assessments is absolutely critical so that you have that contingency plan ready so that you can, if you run into problems. And as we're trying to land atoms on atoms, right, or even sometimes half an atom on atoms, right. So you will have challenges, but the key thing is to have enough options so that the challenge you don't get stuck and slow down.
So as just going a slightly level deeper, because as part of that 10 nanometer development process, Intel at the time spoke about scaling boosters and developments such as contact over active gate, use of cobalt, ruthenium. But Intel never confirmed which ones made it to production or which ones met targets. Would you be able to talk about those that worked or tweaks have made or perhaps improvements that haven't been previously mentioned?
Well, I prefer not to go into the very specifics of a particular process node, but I think out of those, you mentioned a lot of the metals that you've mentioned. They continue within our overall part of the periodic table that we continue to use. Contact over active gate had its benefits. I think overall, in terms of those areas that gave us the real challenge, one or two we have moved away from, and others we have kept because we've learned significantly on how to basically get them to work very, very appropriately in the nodes. And I think one of the other
What?
things is, Ian, as we moved on to Intel 4, We didn't need some of them because Intel 4 is the first process node where we're basically using EUV, and that eliminated and allowed us to streamline our process flow and absolutely eliminated some of the need for some of for those, I'm going to say, the tricks that we were using to get to the smaller dimensions.
You've actually answered my next questions, because I was going to ask why Intel relied more on, self-aligned quad patterning and other boosters rather than bringing EUV. But it just sounds like the process node, how it was just developed, just the timing just mismatched
The timing
entirely
mismatch.
almost.
Yes, and that's why one of our key learnings going forward is we'll have that flexibility going forward, so that if there is a mismatch, that we don't again get caught with a mismatch.
It's when I was in D1X, I did go up straight up to the EUV machines up close. Bruce was there. I touched one and then got told off for it. Also fun to look inside it as well, because you guys still are installing so many of these machines.
Yes,
So
sure.
when High NA comes around, if by some reason it's not ready or there are other challenges, could I surmise from what you're saying that future nodes that are along those time frames, if it's ready earlier, the idea is to bring it in earlier, or if it doesn't arrive as intended, that there's flexibility for those layers that may or may not have been High NA?
Correct. We're aiming to introduce it in 2025, but we're setting up our processes so that if for some whatever reason High NA is not ready, then we will be able to continue without it. If High NA is, as soon as High NA is ready, then we'll be able to put it into our product and use it.
So I think I saw a cat.
I know, I'm sorry.
Oh, that's perfect.
Sneak shadow.
Intel already has High NA development machines. They've got the first gen NXE 5000, and it's just been announced that you've ordered the second generation NXE 5200. That's going to come in from ASML. What exactly have you been using the High NA machine that you have, if you have more than one? That's not public. But what
Well,
have you been using them for to date?
the High NA machine hasn't arrived just yet. Actually,
The
I was
5000.
No, it is not. That is currently being
Oh,
built for us, right? For us within ASML. When I visited ASML late last year, I saw all the pieces as it was being built and put together. But we're also working with ASML and with IMEC in their lab. As soon as their first High NA tool is available we will be running some of our experiments in their lab on that. So then we will be starting early. So that as soon as the 5,000 docks, then we'll be able to cut over and then you run it in our own fab. So we have a very active team working right now with ASML, and those teams are working in terms of through all the line items that needs to get done, so that by the time the 5,000 arrives, that we're good to go and good to go on the development work in our fab.
when I'm quoted how long it takes to install an EUV machine and tune it, usually it's about 6 months for each. Would the first gen high end EUV machine be a similar, or are you trying to increase that?
Well, we're always trying to drive down the qual time, because we're always trying to drive down the qual time. Right now I'm not in a position to quote what its final qual time will be, but we will be taking as much as possible learnings out of the install calls of the 0.33 basically to apply them to the 0.5. Work to be done is the simplest way of putting it.
So on a more wide scale, so a lot of foundry offerings currently now by the pure plays are built on long-term nodes and form large parts of their market, whereas other nodes disappear as quickly as they appear, almost. So we're seeing other foundries offer long-term 7 nanometer, 5 nanometer. Is there anything different that TD does when it comes to that mindset of creating a long life node versus something perhaps a bit shorter?
Not really. And I would say not really because when we set up our nodes for running within our factories, we're driving for high yields, we're driving for really meeting all our RAL criteria. and ensuring that the process node can run at its best. And then when it's in volume, we continue to run on some performance and enhancement improvements. I think longer term, when the nodes are running within the factories, they may requests may come from customers that require some unique work or some unique development work. We would then be supporting that, but it would be very much based on some unique or custom requests from the customers rather than doing other than our work at continuing to improve yields, continuing to drive down costs, all of the work that we always do. So I think the unique piece would be based on any unique customer asks.
That actually leads into one of my upcoming questions about design technology co-optimization, or what the industry is called DTCO,
Right.
marked by other foundries as key driver to optimize specific customer products on leading edge nodes. Does TD have a plan when it comes to that sort of extended DTCO, either with internal customers or future IFS customers?
Yes, it does. We have a very active program internal on DTCO. That program has been running with several years, right? It's been working with our internal design teams. Similar with our IFS customers, TD and the IFS organization work with customers to ensure that the DTCO happens appropriately for the particular product and the particular requirement of customer. And it's a key
Uh,
part of the work that we do today.
So during Intel's 10 nanometer rollout, it was clear that the node information from outside of the fence was hard to come by because Intel didn't really want to talk about what was going on. Pat right now is talking about being more open, whether that's software, product, engineering. So as Intel migrates into the IFS model, how open are you expecting the technology development team to be when it comes to major and minor tweaks?
Well, I'll start with saying, I mean, if you think about our July event last year, it's probably the first time we've ever been that open in terms of where we became very clear in terms of our roadmap out as far as 2025. With given customers, we're fully transparent in terms of our process. We're fully transparent in terms of our data, and we're fully transparent in terms of working with our customers in terms of meeting their needs. So I think it's very situational with our customers. We're fully transparent. We then at a higher level we've opened up quite a lot to. So I think it'll be very situational depending on the particular ask.
The other pure play foundries in the market, when they develop new nodes and new packaging offerings, especially, they work with leading customers for a particular process or particular technology. Historically, Intel's customer for that leading edge has been itself. But with IFS, that has the potential to change. Do you expect to be working with foundry customers when it comes to next generation process nodes rather than something more internal?
I expect we'll be working with both, right? It could very well be that an external customer is ahead of the internal. That could happen, right? But equally well, our internal customers also move on to our new nodes. So I expect that we'll be working with both, and we have key learnings from both.
Moving back to the tools, because I've spoken with Cadence and Synopsys, the EDA tool vendors, and they're talking about AI accelerated offerings when it comes to PDK integration and development. Can you talk about what elements of Intel's process node development are currently using machine learning and exactly how that's integrated?
I speak very much from, first of all, we do work with the EDA vendors that you're talking about, and we do work quite a lot in terms of the feedback from the work we do with them back into the TD organization, the process development organization. But if I look across my entire process development organization, we use AI. I mean, it depends on what you want to call it. You have some people call it machine learning, some people call it advanced analytics, some people call it AI. But we use all of those tools in many areas of our process. We have a lot of process control, which is tied into the equipment process steps, which is, and we feed forward information, we feed backward information in terms of to previous steps. So across the process, we have a lot of work, and a lot of our benefits that we've got in our recent nodes has because of the use of AI, machine learning, etc. And that is a key strand in one of my groups, which reports to me in terms of how we continue to move that frontier forward, and how we basically apply the best of all the technology, of our own technology, back into our factories.
Based on the financials that recently happened, we're seeing Intel increasing investment into R&D overall. Are you seeing some of that in TD? Where is it going, and is it enough?
Yes, yes, and yes. Right. So yes, I'm seeing increased investment into TD. Where is it enough? Yes, for now. I'm sure I'll always have my hand out for more, right? Because there's always more work I can do. But I also need to be pragmatic and realistic. I am spending more money in process development. I'm spending more money on some more advanced research, and I'm spending more money on package development.
Is there an aspect of TD or Intel's TD approach you think is under-promoted to the wider audience?
I think I could promote some of the work we do in components research a lot more, because that's the frontier of moving Moore's law. And I think also over the history, we tended not to talk a lot, right? You probably didn't get to speak to many TD folks over the years, and I think I'm opening that up because I want people to get a visibility into some of the wonderful work that the engineers do.
And final question, because you brought up Pat's comment about exploring the periodic table, what's the weirdest element Intel's explored?
I'm not sure. I'm not sure, to be perfectly honest. So maybe I should come back to you with the answer in that.
That's perfect. Thank you, and so much
You're
for
welcome.
taking your time out to speak to us. It's been great. Thank
You're
you.
very welcome. I'll come back to you with that, Ian.
If you like this content, please don't forget to like and subscribe. We also have now a private Discord server, and if you want access to that, become a Patreon member and it will instantly add you as long as your emails are linked. You can join the Patreon for as little as $1.50 a month, and it all goes back into helping the channel. Thank you for your support.